Okay, so a crate of mass 15 kilograms is placed on the floor of a lift. Calculate in newtons the magnitude of the reaction of the floor on the crate. So here's your crate here, right, of 15 kilograms on the floor. And of course the weight then will be mass times G, so 15 times G, or 15 times 9.8. And there'll be a reaction from the floor. Okay, so if we focus on these forces here, we're also told in part A, when the lift is descending, so descending, of course, means it's going down, okay? Descending, going down. But it says with a retardation of 2. So you can see here, I've got my direction of acceleration going downwards, okay? Because the lift is going downwards. But of course, then I've written in A is actually equal to -2 because it's got a uniform retardation, okay? In other words, it's decelerating, okay? So it's slowing down, okay? But it's important to have the acceleration pointing downwards just to show the direction of the lift, all right? So what I'll do then is, using Newton's second law, okay, and I say in the direction of motion, okay, in the direction of motion. That's why I'm taking the accelerations going downwards, because that's the direction of motion. So if we look at the resultant force, well, because it's going downwards, 15G, okay, will be the leading force, because that's the direction it's going in. So that's like the forward force going downwards. And you take away then the reaction force, okay, which is opposing the direction of motion. And that will equal then to mass times acceleration. So the mass is 15 times the acceleration, which happens to be -2. Okay? So then we can put 15 times 9.8 here. Take away r, and that will of course will equal 30. Or -30, and then if I take that minus r over that side and bring the -30 this side, I'll be able to get my answer. So on my calculator, if I work out that first, 15 times 9.8 is 147. Bring that -30 over, becomes +30, and then that equals r. So then r then clearly will be 177 newtons. Okay. Part B, it's only worth 1 mark. When the lift is ascending at a constant speed of 3 meters per second. Okay, so they mentioned the speed here, right? Whereas before they mentioned the deceleration, but here they mentioned the speed. And you've got to ask yourself how relevant that is, okay? Because when we look at the diagram I've drawn, it is ascending, it's going up, okay? But it's going at a constant speed, yeah? Constant speed of 3 meters per second. Now, the important bit for me is this here, constant speed. I'm not really bothered about what the speed is. If it's going at a constant speed, we can say the acceleration is 0, can't we? So again, using Newton's second law, in the direction of motion, it's going up. The forward force will be r. Take away then the 15g, which is going the opposite way, opposing motion. That will equal then to mass, which is 15, times the acceleration. Of course, the acceleration is 0, isn't it? Because it's constant acceleration, because it's constant speed rather. Because it's constant speed, acceleration is not accelerating. Speed isn't changing, it's staying at the same speed. So in that case then, you get r minus 15g equals 0, which basically means r is equal to 15g, okay? So they're equal to each other. Upwards equals downwards, and then all you've got to do is work out 15 times 9.8, which we did before, of course, and we get 147 newtons.